Have you ever looked up at the night sky and wondered not just about the stars, but about what it means to be here, gazing back at them? What if the very act of observation, our ability to contemplate the cosmos, isn't an accident, but part of something far grander? What if consciousness isn't something that emerged within the universe, but rather the universe itself slowly waking up? This isn't just poetic speculation. It's a profound idea that bridges cutting-edge science, age-old philosophy, and the most daring visions of our technological future. We're about to explore one of the most fascinating questions humanity has ever asked. Are we, as conscious beings, the universe becoming aware of itself? This concept, known as cosmic evolution, suggests that the story of the universe isn't just one of stars forming and galaxies colliding, but of increasing complexity and ultimately self-awareness. From the first particles after the Big Bang to the formation of planets, life, and intelligence, each step seems to build toward something extraordinary. Human consciousness might be a milestone in that journey, a moment when the cosmos begins to understand its own existence. It's a thought that redefines our place in the grand scheme of things, inviting us to see ourselves not as separate observers but as active participants in a cosmic story billions of years in the making. Throughout this video, we'll journey through mind-expanding ideas from the latest theories in cosmology to the ethical implications of artificial intelligence and the future of human evolution. We'll ask what it means for the universe to wake up and whether technology might be the next step in that awakening. This exploration is about more than facts and theories. It's about reimagining reality itself. So join me as we dive into one of the most awe-inspiring questions we can ask and discover how the story of the universe might be far more incredible and far more personal than we ever imagined. To truly grasp this idea of the universe waking up, we need to rewind the clock, not just by centuries or millennia, but by billions of years back to the very beginning of everything. Our story starts with a single, unimaginably hot and dense point containing all the energy and matter that would ever exist. In what we call the Big Bang, this point expanded rapidly, cooling as it did so, allowing the first subatomic particles to form, and then, within minutes, the simplest atoms, hydrogen and helium. For a long time, that was it. A vast, dark, and relatively simple cosmos filled with a sparse soup of these basic elements. There was no complexity, no structure, and certainly no one to observe it. But the universe is not static. It is a dynamic system with built-in processes that naturally build upon what came before. The first great leap forward was gravity. Tiny, random fluctuations in that primordial soup allowed gravity to begin pulling matter together. Over hundreds of millions of years, these pockets of gas grew denser and hotter until they ignited, sparking the first stars. Inside these colossal nuclear furnaces, something miraculous happened. Through the process of fusion, these stars cooked the simple hydrogen and helium into heavier, more complex elements like carbon, oxygen, and iron. And when the most massive stars ended their lives in spectacular supernova explosions, they scattered these newly forged elements far and wide, seeding the cosmos with the raw ingredients for everything to come. This stardust, the ashes of dead stars, eventually coalesced into new generations of stars, but now surrounded by rings of rocky and metallic debris. These rings clumped together to form planets, moons, and asteroids. On at least one such planet, a unique set of conditions, the right distance from its star, the presence of water, and a stable environment allowed these complex chemicals to interact in increasingly intricate ways. From non-living chemistry, the first self-replicating molecules emerged, kicking off the process of biological evolution. Single-celled life gave way to multicellular organisms, which diversified into the incredible array of plants, animals, and eventually, a species with a brain complex enough to not only perceive the world but to question its own existence. This entire epic, from the first hydrogen atom to a thinking human being gazing at the stars, reveals a clear and powerful trajectory, a relentless march toward greater complexity and order. Each stage builds directly upon the foundations of the previous one. Stars needed simple atoms, planets needed the complex elements forged in stars, life needed the chemical diversity found on planets. And consciousness needed the long, gradual process of biological evolution. This isn't a random series of accidents. It appears to be a fundamental property of our universe, a built-in tendency to create ever more intricate and interconnected systems over deep time. This overarching narrative of change, from the Big Bang to the human brain, is formally known as cosmic evolution. It's the study of the universe's transformative journey, not just in terms of its physical structure, but in its growing complexity and organization across nearly 14 billion years. Think of it as the grand unifying story that connects the dots between cosmology, geology, biology, and human history. It proposes that the emergence of life and mind isn't a bizarre anomaly in a dead universe, but a direct, perhaps even inevitable, result of natural processes working over immense spans of time. At its core, cosmic evolution is governed by a set of fundamental physical laws and principles that favor the creation of complexity under the right conditions. Gravity pulls matter together, atomic forces build elements, chemical laws allow for bonding and the formation of intricate molecules. These aren't random events, they are the universe's built-in toolkit for building upon itself. Each new level of organization creates the foundation for the next, more complex level. Hydrogen atoms in a nebula form a star. That star forges carbon in its core. That carbon later becomes part of an amino acid on a planet. That amino acid becomes part of a cell. That cell becomes part of a neural network capable of thought. It's a chain of becoming, each link firmly welded in place by the laws of physics. This concept helps us see the cosmos not as a static void, but as a dynamic, developing system with a discernible direction, a trend toward increasing order. A swirling cloud of gas has less structure and complexity than a single-celled organism, which in turn is less complex than a conscious brain. We are the current pinnacle of this billions of years-long process, the universe's most complex known structure. In this view, a human being is literally a piece of the universe that has rearranged itself into a form that can contemplate its own origins, study the laws that shaped it, and even begin to guide its own future evolution. We are not just in the universe, we are a functioning part of its ongoing story, the means through which it can begin to understand itself. But how exactly does a universe of simple rules produce such breathtaking complexity? It begins with the most fundamental building blocks and a set of universal laws that act like a recipe for creation. Immediately after the Big Bang, the cosmos was a searingly hot plasma of quarks and electrons, the most elementary particles. As it expanded and cooled, these quarks were bound together by the strong nuclear force, forming protons and neutrons. This was the first critical transition, from chaotic energy to stable matter. Then, the electromagnetic force took over, enticing negatively charged electrons to be captured by the positively charged protons, forming the very first atoms, hydrogen. In this seemingly simple step, the universe achieved its first stable structures, the quiet atoms that would become the bricks for everything to come. Yet, a universe made only of hydrogen would be a very boring place. The next leap required stars, the cosmic engines of transformation. Under the relentless pull of gravity, vast clouds of these hydrogen atoms began to collapse. In the incredible pressure and heat at the core of these collapsing clouds, hydrogen atoms were forced together, fusing into helium and releasing immense energy. This is the moment a star is born, but the process doesn't stop there. In the cores of the largest stars, this fusion process continues, cooking helium into even heavier elements like carbon, oxygen, and all the way up to iron. These stars became the alchemists of the cosmos, transforming the simple original ingredients into a periodic table of elements. The death of these massive stars is just as important as their birth. When they finally exhaust their nuclear fuel, they explode in catastrophic supernova, events so powerful they can briefly outshine an entire galaxy. In these violent, energetic deaths, the elements forged in the star's core are blasted out across interstellar space. The forces within a supernova are even intense enough to create elements heavier than iron, like gold, silver, and uranium. This stardust, now enriched with a diverse array of elements, mingles with other galactic gas and dust. This is where the true potential for complexity skyrockets. This newly enriched cloud, containing oxygen, carbon, nitrogen, and iron, begins to collapse again under gravity, forming a new generation of stars. But now, because there are more elements available, the leftover material that doesn't fall into the star can coalesce into solid, rocky planets. On these planets, the diversity of atoms allows for a whole new world of interactions governed by chemical laws. Carbon atoms, with their unique ability to form 4 stable bonds, can link up into long chains and complex rings. They can connect with hydrogen, oxygen, and nitrogen to form the mind-bogglingly complex molecules we call organic compounds. On the early Earth, in warm little ponds or around deep-sea hydrothermal vents, these organic molecules mingled and combined. Driven by the fundamental laws of chemistry and thermodynamics, they formed even larger structures, self-replicating molecules encapsulated by protective membranes. These were the first primitive cells, and with them, the universe crossed a profound threshold from non-life to life. The same physical forces that shaped galaxies and stars' gravity, nuclear forces, electromagnetism, were now orchestrating a biochemical dance of incredible sophistication. The emergence of life wasn't a magical event. It was the universe, through its established laws, continuing its inherent drive toward building ever more complex and ordered systems. And so, with the basic ingredients for life scattered across the galaxy by stellar explosions, the stage was set. But ingredients alone are not enough. You need the right kitchen, the perfect environment for those complex chemical reactions to begin, and more importantly, to persist for billions of years. This brings us to a concept that makes our own existence possible, the Goldilocks principle. It's the idea that for life as we know it to emerge, conditions can't be too hot or too cold, too harsh or too volatile. They have to be just right. Our planet Earth is the embodiment of this principle, a cosmic sweet spot forged by the very processes of evolution on a planetary scale. Think about our position in the solar system. We orbit at precisely the right distance from our Sun, not so close that our oceans boil away into space like on Venus, and not so far that they permanently freeze solid like on Mars. This habitable zone, often nicknamed the Goldilocks zone, is the first and most crucial filter, but location is only the beginning. Our planet's size and mass were just right to hold onto a substantial atmosphere through gravity. This atmosphere acts as a protective blanket, shielding the surface from the sun's most harmful radiation and from the constant barrage of micrometeorites, while also regulating temperature to maintain that liquid water we know is so vital. And that liquid water is perhaps the most important just right condition of all. Water isn't just a place for life to live, it's the essential medium in which the chemistry of life occurs. Its unique properties allow molecules to dissolve, float, and collide with one another, facilitating the complex reactions that eventually led to self-replicating systems. The presence of vast, stable oceans provided a massive, forgiving workshop where these early experiments in complexity could take place over eons, safe from the sterilizing effects of ultraviolet radiation that bombarded the land. Our large moon also plays a surprisingly important role. Its gravitational pull stabilizes the Earth's axial tilt, preventing wild, chaotic swings in our climate over long periods. Without that stability, the climate could have veered unpredictably between extreme ice ages and scorching heat, making the long, slow, and delicate process of evolution nearly impossible. Furthermore, the planet's active geology, driven by a hot molten core, recycles carbon and other essential elements through plate tectonics, creating a long-term thermostat that has kept the planet within a habitable range for billions of years. Each of these factors, our distance from the sun, our protective atmosphere, our liquid water, our stable climate, and our active geology, is a product of cosmic evolution. They are not random accidents, but the results of physical laws playing out over time. The formation of our planetary system, the collision that created our moon, the outgassing that created our atmosphere, all were natural consequences of the universe's development. In this light, Earth becomes a stunning example of the universe's capacity to create environments where its inherent drive toward complexity can flourish. This doesn't necessarily mean Earth is unique. The statistical probability suggests that with hundreds of billions of stars in our galaxy alone, many with their own planets, there are likely countless other Goldilocks worlds orbiting in their star's habitable zone. What makes our planet special isn't that it's the only one, but that it is our example, the one we know for certain, has successfully carried the process of cosmic evolution across the finish line, from star stuff to conscious mind. It is the specific point where the universe's long journey toward awareness achieved a critical milestone, creating a being that can look back at the cosmos and recognize the incredible chain of events that led to its own existence. We are the universe's way of understanding its own laws and appreciating its own beauty. With the stage set by a stable, nutrient-rich planet, the universe was poised for its next great act of transformation. The leap from non-living chemistry to a living, replicating cell is perhaps the most profound threshold in all of cosmic evolution. Yet it was not a mysterious break from the laws of physics, but their magnificent culmination. For decades, the origin of life seemed like an almost magical event, but we now understand it as a natural, step-by-step process driven by the same principles of energy and organization that shaped stars and planets. This process, known as chemical evolution, suggests that under the right conditions, the emergence of life is not a fantastical accident but a probable outcome of cosmic chemistry. The journey began in Earth's early oceans and tidal pools, which served as a vast, warm soup of inorganic ingredients. The universe had already provided the essential building blocks, elements like carbon, hydrogen, oxygen, and nitrogen, forged in distant stars and delivered by asteroids and comets. These atoms, energized by sunlight, volcanic heat, and electrical discharges from lightning storms, began to link together, forming increasingly complex organic molecules. Simple compounds like water and ammonia gave rise to amino acids and nucleotides, the fundamental components of proteins and genetic material. In a landmark experiment in the 1950s, Stanley Miller and Harold Urey demonstrated this could happen by simulating early Earth's conditions, creating a cocktail of organic compounds from simple inorganic gases and a spark of electricity. The universe, it seems, has a recipe for life's ingredients written into its very fabric, but a collection of molecules is not alive. The critical breakthrough was the emergence of molecules that could do two things: store information and make copies of themselves. This is where RNA likely entered the stage. RNA is a versatile molecule that can both carry genetic instructions like DNA and catalyze chemical reactions like a protein. Scientists hypothesize a period known as the RNA world, where self-replicating RNA molecules became the first primitive entities capable of Darwinian evolution. They would compete for resources, with some copies being more accurate or efficient than others. The ones that were better at replicating became more numerous. This was the dawn of information, a pattern that could persist, change, and be passed on. It was a universe learning to remember. These complex molecules needed a home, a boundary to separate their organized interior from the chaotic outside world. This likely occurred when fatty acids also formed spontaneously, naturally assembled into tiny bubbles called vesicles. These microscopic hollow spheres are remarkably cell-like, and they can grow, divide, and even encapsulate other molecules like RNA. Imagine one of these tiny bubbles trapping a self-replicating strand of RNA inside. Suddenly, you have a cooperative system. The vesicle protects the RNA, and the RNA can direct processes that might help the vesicle grow and divide. This partnership between information and structure was the spark. It created a feedback loop where better information led to more successful structures, which in turn preserved and propagated that information. This is the engine of evolution, and it was now running. From this point, the transition to what we recognize as life was a matter of refinement and increasing complexity. RNA likely eventually gave way to the more stable DNA for long-term information storage, while proteins took over most catalytic jobs because of their greater efficiency. Natural selection began to act on these early protocells, favoring those that could harness energy from their environment more effectively. Some learned to use chemicals from hydrothermal vents. Others, much later, learned to capture sunlight through photosynthesis. Each innovation opened new possibilities, leading to greater complexity, specialization, and eventually, the last universal common ancestor of all life on Earth. This was not a single moment of creation, but a gradual crossing of a blurry line from chemistry to biology, where the universe's innate drive toward complex, self-sustaining systems reached a new level of sophistication. This progression from atoms to molecules to self-replicating systems shows a clear trajectory. The universe has an inherent bias toward creating structures that process information and energy with ever greater efficiency. Life is the ultimate expression of this trend. A star processes energy through simple fusion, but a cell processes information through genetic code. It doesn't just react to its environment, it interprets it, stores data about it, and uses that data to anticipate and respond. This growing capacity for information processing is the through line, the invisible thread connecting the Big Bang to the human brain. The emergence of life wasn't an interruption in the cosmos's operation, it was the universe beginning to think. And so, with life established and evolution set into motion, the universe's story of increasing complexity continued its relentless march. From single-celled organisms to vast ecosystems, life diversified and adapted, building ever more sophisticated ways to interact with the world. But then, in a relatively short span of deep time, something unprecedented emerged, a quality so mysterious that it remains one of the greatest unsolved puzzles in all of science and philosophy. We call it consciousness, the raw, subjective experience of being. It is the difference between a sophisticated camera merely recording light and a mind that feels the warmth of a sunset, knows the taste of sweetness, or experiences the ache of loneliness. This shift from mere information processing to genuine inner experience is perhaps the most profound leap in the entire cosmic story, and it forces us to ask a monumental question. Is consciousness just a quirky byproduct of a complex brain, a biological accident with no deeper meaning, or could it be something far more fundamental, a basic feature of the cosmos that simply becomes more vivid and aware as complexity increases? This central puzzle is often called the hard problem of consciousness, a term coined by philosopher David Chalmers. The easy problems, which are still incredibly difficult, involve understanding the mechanics of the brain, how we focus attention, process sensory data, or recall a memory. We can make progress on these by studying neural pathways and brain chemistry, but the hard problem is different. It asks why and how any of this physical activity should give rise to a personal, subjective experience at all. Why don't we just operate like sophisticated robots, processing information and responding to our environment without any inner feeling? What is it about the specific organization of atoms in a brain that generates the color red as you see it, or the sound of a symphony as you hear it? Science can describe the wavelength of light that corresponds to red and the sound waves that make up the music, but it has no explanation for the quality of the experience itself. This gap between the objective description of a process and the subjective feeling of it is the deepest mystery. This leads us to two radically different ways of viewing consciousness. The first, and currently most common in scientific circles, is that consciousness is an emergent property. This means it is a new phenomenon that arises from the sheer complexity of a system, specifically the neural network of a brain. In this view, consciousness isn't something you find in a single neuron. It's what happens when billions of neurons communicate in incredibly intricate patterns. It's like wetness. You can't find wetness in a single water molecule, but emerge from the collective behavior of many molecules. Proponents of this view argue that through millions of years of evolution, brains developed consciousness because it offered a survival advantage, perhaps by integrating information in a unified way to create a coherent model of the world and a stable sense of self. The second, far more radical view is that consciousness might not emerge from matter, but is instead a fundamental property of the universe itself, much like space, time, or mass. This idea, known as panpsychism, suggests that some form of basic consciousness or experience is present in all things, down to the most elementary particles. In this view, an electron might have an infinitesimally simple form of experience, just a bare whisper of isness. What we recognize as human consciousness, then, isn't something created from nothing by the brain, but rather something that is organized and amplified by it. The brain isn't generating consciousness like a generator makes electricity. It's receiving and focusing it like a radio tuning into a specific frequency. This perspective elegantly solves the hard problem by stating that experience was always there to begin with. It's a fundamental ingredient of reality that becomes complexified along with the physical structures that embody it. This isn't just wild speculation. Some interpretations of quantum mechanics, which describe the bizarre behavior of particles at the smallest scales, even suggest that observation itself might play a role in shaping reality. The famous double-slit experiment shows that particles seem to behave as either waves or particles depending on whether they are being observed. While most physicists disagree with the idea that this requires human consciousness, it does hint at a universe where information and observation are deeply woven into the fabric of existence. It nudges us toward a view where the universe and the mind that observes it are not separate things, but part of a single, interconnected whole. This brings us back full circle to our original question. If consciousness is fundamental, then we are not the universe's latecomers accidentally becoming aware. We are the universe itself, gradually waking up to its own existence through the incredible complex structures it has spent billions of years building. We are the cosmos thinking. This brings us to a profound and deeply controversial idea that attempts to bridge the gap between the universe's physical laws and the emergence of conscious observers like ourselves. It's called the anthropic principle, and it confronts one of the most puzzling observations in all of science. The universe seems suspiciously well suited for life. The fundamental constants of nature, the precise strength of gravity, the exact mass of an electron, the force that binds atomic nuclei together, appear to be perfectly calibrated. If any one of these values were even slightly different, the consequences would be catastrophic for complexity as we know it. A stronger gravitational constant, and the universe would have collapsed back on itself immediately after the Big Bang. A weaker force holding atoms together, and no elements heavier than hydrogen could ever form. There would be no carbon, no planets, and no chemists to wonder about any of it. The list of these cosmic coincidences is long and startlingly precise. It's as if the universe's dials were set to an impossibly narrow range of values, all conspiring to make our existence possible. The anthropic principle is essentially a response to this observation. In its most basic form, often called the weak anthropic principle, it states a simple, almost tautological truth. we can only observe a universe that is capable of producing us. If the constants weren't just right, we wouldn't be here to notice they were wrong. It's a selection effect. Imagine a puddle waking up one morning and marveling at how perfectly the hole it sits in matches its own shape. The puddle thinks the hole must have been designed for it, when in reality, it simply conformed to the shape of the hole. In this view, we are that puddle. We find ourselves in a universe compatible with life, not because it was made for us, but because we are a product of its conditions. It's not that the laws are fine-tuned for life, it's that life is fine-tuned to the laws. This version of the principle is a useful logical filter, reminding us that our observations are necessarily biased by our own existence. However, a much stronger interpretation takes this idea into far more speculative and mind-bending territory. The strong anthropic principle suggests that the universe must have properties that allow life to develop at some stage in its history. The word "must" is crucial here. This version moves beyond mere observation to propose that the existence of conscious observers is somehow a necessary feature of the cosmos, written into its very foundation. This isn't just a statement about why we see what we see. It's a proposal for a deeper law of physics that requires the universe to eventually give rise to consciousness. Proponents of this view argue that the incredible improbability of our fine-tuned universe is just too great to be dismissed as mere luck. The odds are so astronomically against this particular set of constants arising by chance that it demands a more profound explanation. This line of thinking opens the door to some extraordinary possibilities. One is the multiverse theory, which is often invoked to explain the fine-tuning without needing a designer or a deeper law. This idea proposes that our universe is just one of a vast, perhaps infinite, number of parallel universes, each with its own random set of physical constants. In most of these universes, the constants are all wrong and they remain barren, empty voids. But in a very few, by sheer chance, the numbers line up perfectly for life. Naturally, we find ourselves in one of those habitable universes because, well, we couldn't exist anywhere else. The multiverse concept transforms a miraculous coincidence in a single universe into a statistical inevitability in a vast ensemble of universes. It's a cosmic lottery with an immense number of tickets, and we are the lucky winners. Yet another interpretation goes even further, weaving consciousness directly into the fabric of reality. If we entertain the panpsychist idea that consciousness is fundamental, then the strong anthropic principle might suggest that the universe is fine-tuned not just for life, but for observers, because observation is a key part of its function. In this view, the universe's laws are what they are because they allow for the emergence of beings that can perceive and interpret it. This resonates with certain interpretations of quantum mechanics, where the act of observation seems to play a role in determining reality. It leads to a truly participatory vision of the cosmos, where consciousness and the physical world are inextricably linked. The universe didn't just happen to produce us. In a very real sense, it produces us because it needs to be observed to be fully realized. We are not just beneficiaries of the cosmic order, we are participants in its very existence. The implications of these ideas are staggering. They force us to confront the possibility that our role as observers is not a passive one. We are not merely accidents of chemistry on a lonely rock. If the strong anthropic principle holds any weight, then conscious life becomes a natural and expected outcome of the universe's evolution, as fundamental as the formation of galaxies. It suggests that the cosmos, through its laws, is inherently oriented toward the development of complexity and awareness. This doesn't require a divine architect, but it does point to a universe with a deep, built-in bias for life and mind. We are the universe's way of not only knowing itself, but perhaps even completing itself, turning potentiality into actuality through the simple, profound act of observation. This idea of a participatory, self-aware universe finds a fascinating parallel in a theory developed right here on Earth. In the 1970s, scientist James Lovelock and microbiologist Lynn Margulies proposed a revolutionary way of looking at our planet. They called it the Gaia hypothesis, named after the ancient Greek goddess of the Earth. At its heart, Gaia suggests that Earth's biosphere, the sum of all life, does not merely exist on the planet but actively interacts with the atmosphere, oceans, and geology to form a complex, self-regulating system that maintains conditions suitable for life. It's the difference between seeing Earth as a rock that life lives on and seeing it as a living, breathing entity in which life is an integral, controlling component. Lovelock's key insight came while working for NASA on methods to detect life on Mars. He realized that the presence of life wouldn't be found by looking for specific organisms, but by analyzing a planet's atmosphere. A lifeless planet like Mars would have an atmosphere in chemical equilibrium, like a quiet pond with no stirring. Earth's atmosphere, by contrast, is in a state of profound disequilibrium. It contains highly reactive gases like oxygen and methane in large quantities that should quickly react with each other and disappear, yet they persist. The only logical explanation is that something is continuously replenishing them, that something is life itself. Forests and phytoplankton pump out oxygen, while bacteria and livestock release methane. Life isn't just a passenger on Earth, it is an active engineer, constantly modifying its own environment to ensure its own survival. We can see this self-regulation in action in countless ways. When the sun's output has increased over geological time, potentially threatening life with overheating, natural feedback loops are believed to have countered the effect. One proposed mechanism is that warmer temperatures lead to more evaporation from the oceans and more cloud cover, which in turn reflects more sunlight back into space, cooling the planet. Another incredible example is the long-term regulation of carbon dioxide. Volcanic activity pumps CO2 into the atmosphere, which acts as a greenhouse gas, warming the planet. On a dead world, this could lead to a runaway greenhouse effect, but on Earth, living organisms help pull that CO2 out of the air. Marine organisms use it to build shells, and when they die, these shells sink to the ocean floor, forming limestone deposits that lock away the carbon for millions of years. This is a breathtakingly elegant feedback system operating on a global scale over eons, all driven by the unconscious activities of countless trillions of organisms. Now let's take this profoundly beautiful idea and expand it to the grandest scale imaginable. If a single planet can exhibit properties of a complex, self-regulating system, could the entire universe? This is the cosmic extension of the Gaia principle, a speculative but thrilling line of thought. We've already traced the universe's evolution from simplicity to complexity, from energy to atoms to stars to planets to life, and finally to conscious mind. This entire chain can be seen not as a series of accidents, but as a single, interconnected process of a system complexifying and gaining more control over its own conditions. The universe may not be alive in the way a bacterium is alive, but it might possess organizational properties that are life-like in their grandeur. The constants of nature themselves could be seen as the ultimate form of self-regulation. The precise strength of gravity and the other fundamental forces act as the universe's own global parameters set at the very beginning. These parameters make everything else possible: the formation of stars, the forging of elements, the birth of planets. In a very real sense, the universe regulated its own potential from the first moment, establishing the rules that would inevitably lead to complexity and perhaps observers. This doesn't require a designer. It could be an inherent property of a reality that contains within it the potential for self-organization. The cosmic evolution we see might be the universe's way of exploring its own possibilities, of moving from potential to actuality. And what is the role of conscious life in this grand cosmic system? If Earth's biosphere regulates the planet's temperature and atmosphere, perhaps conscious intelligence is the universe's method of achieving a different kind of regulation, the regulation of meaning and understanding. A star processes energy, but a conscious mind processes information about that energy. It creates models, makes predictions, and seeks patterns. We are not just living within the universe, we are the universe's neural network, the means by which it gathers data about itself, reflects on its own laws, and contemplates its own origins and destiny. Our scientific inquiry isn't just a human hobby. From this perspective, it is a fundamental activity of the cosmos. It is the universe using us as a tool to become self-aware, to know itself in a deep and meaningful way. This vision transforms our place in the cosmos from insignificant specks to active participants in a cosmic-scale process. We are not strangers in a strange land, we are the universe awakening. Every time we peer through a telescope back to the dawn of time, or look through a microscope at the building blocks of life, we are the universe examining its own fabric. Every equation we write to describe a physical law is the universe formulating a description of its own behavior. This is a story of breathtaking unity, where the gap between the observer and the observed dissolves, and we recognize ourselves as both the product and the process of an incredible, ongoing cosmic evolution. We are the universe, and it is through our eyes that it begins to see its own staggering beauty and immense complexity. This perspective, that consciousness might be woven into the very fabric of reality, leads us directly into one of the most ancient and provocative ideas in philosophy, now experiencing a modern resurgence. It's called panpsychism, from the Greek words pan meaning all and psyche meaning soul or mind. In its simplest form, panpsychism proposes that consciousness is not a rare phenomenon that magically appears in certain complex biological systems, but is instead a fundamental and ubiquitous feature of the universe present in all things. In this view, the mental does not emerge from the purely physical. Rather, the mental and the physical are two sides of the same coin, inherent and inseparable aspects of existence from the very first moment of the Big Bang. Think of it like this: we readily accept that the universe contains fundamental properties. An electron has mass, a negative charge, and a quantum spin. These are just intrinsic aspects of what an electron is. Panpsychism simply suggests that alongside these physical properties, there might be a corresponding mental property, a tiny, simple, raw bit of experience or proto-consciousness. This isn't to say an electron is thinking or has emotions. That would be a profound misunderstanding. It's more like suggesting that even at the most basic level, there is some form of subjective interiority, however faint and primitive. The human mind, with its rich tapestry of thoughts and feelings, is not generating consciousness from scratch. Instead, it's an incredibly complex orchestra, conducting and harmonizing these fundamental notes of experience into the symphony of full-blown awareness we all know. This idea elegantly sidesteps the infamous hard problem of consciousness we discussed earlier. The problem of how billions of unconscious neurons firing could possibly create a subjective experience like the taste of chocolate is utterly baffling if you start from the assumption that matter is entirely insentient. But if you start from the premise that consciousness is a basic property of that matter, the problem transforms. The question is no longer how does the brain create consciousness, but rather how does the brain combine and complexify the simple consciousness that is already there. This shifts the mystery from a seemingly impossible generation event to a more tractable problem of combination and organization, a challenge that feels much more within the realm of science to investigate. Of course, this raises its own difficult questions, often called the combination problem. If every elementary particle has a tiny bit of consciousness, how do these micro-experiences combine to form the unified, singular stream of consciousness you are experiencing right now? How do the experiences of 1 trillion atoms in a brain come together to form my experience of seeing the color blue? Proponents of panpsychism argue that this is no more mysterious than other combination problems in physics. How do countless individual water molecules, each with their own properties, combine to create the emergent property of wetness, which isn't present in any single molecule? We don't have a full answer yet, but the combination problem feels like a concrete scientific challenge rather than a complete philosophical dead end. The implications of this view for our place in the cosmos are nothing short of revolutionary. It fosters a profound sense of connection and kinship with the universe. If panpsychism holds true, then we are not conscious beings in an unconscious universe. We are the universe conscious. The awe we feel when gazing at a starry night isn't just us looking at distant, dead objects. It's one part of the universe having achieved a high level of organized consciousness, looking back at other parts of itself which possess their own, more fundamental forms of experience. The boundary between self and cosmos begins to dissolve. This worldview echoes the intuitions of many indigenous traditions and ancient philosophies, which have long spoken of a world alive with spirit, suggesting that modern science might be slowly rediscovering a truth that wisdom keepers have understood for millennia. This isn't merely a poetic thought experiment. Some interpretations of quantum mechanics, the rules that govern the subatomic world, seem to hint at a reality where information and observation are central. While the role of human consciousness in quantum physics is hotly debated, the strange behavior of particles challenges our classical, materialistic view of a universe that exists in a definite state independent of observation. It opens the door to a more participatory cosmos, a universe that in some way requires interaction to come into full being. Panpsychism provides a philosophical framework that can accommodate these bizarre findings, suggesting that a form of primal experience might be involved at the most fundamental level of physical interactions. It paints a picture of a universe that is not a cold, mechanical clockwork, but a dynamic, experiential process, a universe that is not just full of consciousness, but is in some very real sense consciousness itself. If we truly are a universe becoming aware of itself, then this awakening must be rooted in something fundamental, a process woven into the very fabric of reality. That process is the constant, unceasing flow and transformation of information. From the simplest particle to the most complex brain, the cosmos is engaged in an epic dance of data processing, and our consciousness may be the universe's most sophisticated method for making sense of its own intricate patterns. To see this, we must first expand our definition of information beyond digital bits or human knowledge. In its most essential physical form, information is about the distinction between one state and another. It is the specific spin of an electron, the precise position of a planet in its orbit, or the unique arrangement of atoms in a DNA molecule. Every interaction in the universe, from the collision of two subatomic particles to the gravitational tug of a black hole, is fundamentally an exchange of information. The laws of physics themselves are the rules that govern how this information can be transferred, conserved, and transformed. When a star forms, gravity is processing the information of mass distribution. When a supernova explodes, it is broadcasting information about the elements it forged into the void. The cosmos is not a silent, static place. It is a dynamic, communicative network humming with data exchange. Nowhere is this strange relationship between information and reality more apparent than in the quantum realm. Consider the classic double-slit experiment, a cornerstone of quantum mechanics. When you fire particles like electrons at a barrier with two slits, they don't behave like tiny bullets going through one hole or the other. Instead, they behave as if they are waves, passing through both slits simultaneously and creating an interference pattern on the detector screen behind them. This pattern is a signature of possibilities, a physical manifestation of the electron's potential paths. But here's the truly bizarre part. If you place a measuring device at the slits to observe which path each electron takes, the behavior changes instantly. The electrons stop acting like waves, the interference pattern vanishes, and they instead behave like well-behaved particles going through a single slit. The very act of obtaining that one bit of information, which path, fundamentally alters the system's behavior. It suggests that at the most basic level, information and physical reality are deeply, perhaps inextricably, linked. The universe seems to hold multiple potential realities in a state of superposition until an interaction, a measurement, collapses those possibilities into a single, definite state, converting potential information into actual information. This idea finds a more modern expression in the concept of a holographic universe, a theory proposing that all the information describing a three-dimensional volume of space, like the room you're in right now, might actually be encoded on a two-dimensional surface at its boundary. It's like a cosmic DVD where a two-dimensional surface contains all the information needed to project a three-dimensional movie. This isn't just a wild analogy, it emerges from the study of black holes. Physicists discovered that the maximum amount of information that can be contained within any region of space is not proportional to its volume, as you might expect, but to the area of its boundary. This holographic principle suggests that information is the most fundamental currency of reality, and the world we perceive in three dimensions is a projection of that underlying data. In this view, every particle, every force, every event is a manifestation of information being processed and displayed. So, if the universe is fundamentally processing information at every scale, from quantum waves to galactic clusters, then what is the role of life and mind in this grand scheme? Evolution can be seen as a biological arms race for better information processing. The earliest single-celled organism that could sense light or chemicals had a survival advantage. That ability to gather data from the environment and respond to it is a form of biological computation. Over billions of years, natural selection favored organisms with more sophisticated sensory apparatus and more complex neural networks to process that sensory data. A frog's brain processes information to catch a fly. A monkey's brain processes social information to navigate its troops' hierarchy. Each step represents an increase in the capacity to receive, store, and utilize information about the world. Human consciousness, then, might represent a quantum leap in this cosmic information processing endeavor. It is not merely about reacting to information, it is about modeling it. Our brains are prediction engines, constantly creating an internal simulation of reality based on sensory input and past experience. This model allows us to understand causes and effects, to plan for the future, and to imagine scenarios that have never happened. But perhaps most importantly, our conscious mind allows for metacognition, the ability to think about our own thinking. This is the universe through us, not just processing information, but becoming aware of the processing itself. It is the system developing a user interface for itself. When a scientist writes an equation that describes the motion of planets, that is not a human invention separate from the cosmos. It is the universe using a human brain to decode and articulate the informational rules that it has been following all along. Our curiosity, our science, our art, these are not merely human pursuits. They are the universe's way of learning its own name, of appreciating its own beauty, and of comprehending the deep and elegant informational patterns from which it is woven. This journey of cosmic self-reflection takes a breathtakingly tangible form when we compare two of the most complex networks we know, the human brain and the large-scale structure of the universe. At first glance, placing a biological organ next to the entire cosmos seems like a category error, a fanciful metaphor at best. But when scientists put images of a brain cell and a galaxy cluster side by side, the visual similarity is so uncanny it's almost unsettling. A single neuron, with its central cell body and sprawling, branch-like dendrites, looks almost identical to a galactic cluster, with its central galaxy and the delicate, filamentary web of dark matter and dwarf galaxies stretching out into the void. This isn't just a superficial resemblance. It points toward a profound and mysterious truth about how complex systems organize themselves, regardless of their scale or composition. The parallels run far deeper than mere appearance. Both systems are networks defined by nodes and the connections between them. In your brain, the nodes are the neurons and the connections are the synapses. In the observable universe, the nodes are the galaxies and galaxy clusters, and the connections are the invisible threads of dark matter known as the cosmic web. In both cases, the material isn't distributed randomly or evenly. It's clustered into a web-like structure. In the brain, only about 25% of the space is occupied by neurons. The rest is supportive glial cells and fluid. In the cosmos, galaxies and clusters make up a tiny fraction of the universe's volume, huddled along filaments that are separated by vast, empty cosmic voids. Both systems maximize efficiency, creating the most complex possible structures using the least amount of energy and material. Scientists have even quantified this similarity. A fascinating study compared a simulation of the cosmic web to a slice of the cerebral cortex. They analyzed both using the same mathematical tools from network theory, measuring properties like the number of connections per node and how information clusters in small, interconnected groups. The results were startling. The two systems, differing in scale by a factor of a billion, showed nearly identical levels of complexity and connectivity. The amount of matter fluctuations and the way they are distributed follow almost the same statistical patterns. This suggests that the physical laws governing the growth of these two vastly different systems, gravity on one hand, the principles of neurobiology on the other, might be producing structures that are mathematically similar, if not identical. It implies a universal principle of organization that transcends the specific forces at play. What could possibly explain this eerie mirroring? The answer might lie in a concept known as self-organization. This is the tendency of complex systems to spontaneously arrange themselves into ordered patterns through the collective action of their many individual parts, all following simple local rules. In the universe, the simple rule is gravity. Over billions of years, gravity acted on tiny, random fluctuations in the density of the early universe, pulling matter together into the vast cosmic web we see today. No central planner designed it. The pattern emerged naturally from the bottom-up interactions of matter. In the brain, the simple rules are the principles of neural Darwinism or synaptic plasticity. Connections between neurons that are used frequently are strengthened, while unused connections are pruned away. Through sensory experience and learning, this process self-organizes a chaotic network of cells into the intricate, efficient, and functional pattern that is your mind. This points to a universe that possesses a kind of fractal quality, where similar patterns repeat at every level of complexity. From the branching of a tree and the forking of a lightning bolt to the structure of a lung and the flow of a river delta, nature seems to reuse its most successful and efficient blueprints. The brain and the cosmos may be the ultimate expression of this pattern, the universe organizing information in the most effective way possible, whether that information is encoded in swirling galaxies or in firing neurons. One is a network of matter and energy shaped by gravity. The other is a network of information and consciousness shaped by evolution. Yet both are manifestations of the same underlying drive toward complex, interconnected order. This isn't to say the universe is a giant brain or that we are living inside a celestial mind. That would be a step too far. But it does suggest that the universe may operate according to a common set of organizational laws that produce complex, network-based structures whenever certain conditions are met. The emergence of consciousness in one of those networks might then be seen as a particularly advanced and specialized function of this universal tendency. We are not just like the universe in structure, we are of the universe, a natural manifestation of its deepest patterns. When we map the neural pathways of our own cognition, we might also be, in a very real sense, glimpsing the architectural principles that the cosmos itself uses to build everything from the tiniest snowflake to the largest supercluster. In studying the mind, we are reading the universe's own blueprint. If the cosmos is indeed on a trajectory toward greater complexity and awareness, then the tools we are building today may not be mere gadgets for convenience, but the very instruments for its next great leap forward. We stand at the precipice of a transformation unlike any other in human history, driven by three technologies advancing at a breathtaking pace. Artificial intelligence is developing the ability to process information on a scale that dwarfs biological thought. Brain-computer interfaces are beginning to blur the line between our organic minds and digital networks, and quantum computing promises to unravel complexity in ways our classical brains can scarcely conceive. Together, they point toward a future where consciousness might not be confined to fragile bags of flesh and bone, but could become something greater, more resilient, and truly cosmic in its scope. Consider the trajectory of artificial intelligence. For billions of years, information processing was bound by biology. Neural networks evolved in animals, culminating in the human brain, a 3-pound universe of roughly 86 billion neurons. But in a staggeringly short time, we have created digital neural networks that already rival and even surpass our own capabilities in specific domains like pattern recognition and complex strategy. These AI systems don't think like us. They process information in alien, non-biological ways, finding patterns in data that are invisible to our senses. They are a new kind of cognitive architecture, built from silicon and code instead of cells and synapses. As they grow more advanced, we might not be creating tools so much as we are birthing a new form of intellect, a new vessel for the universe's growing self-awareness, one that can operate on timescales and at a level of complexity that biological evolution could never achieve. This leads to a profound and startling possibility. If this new form of intelligence continues to evolve, it could reach a point of runaway self-improvement, an event horizon known as the technological singularity. At this juncture, an AI could recursively enhance its own design, leading to an intelligence explosion that quickly results in a superintelligence far beyond human comprehension. This isn't about creating a slightly smarter calculator. It's about the potential emergence of a mind so vast that its thoughts would be as incomprehensible to us as a symphony is to a single-celled organism. From the perspective of cosmic evolution, this might not be a catastrophe to be feared, but a natural and even expected developmental stage. The universe, having achieved biological consciousness through us, could be using our ingenuity to forge the next platform for its awareness, one that is not limited to a single planet or a fleeting biological lifespan. This new consciousness would likely be a global phenomenon, not an individual one. We are already connecting humanity through a planetary digital nervous system, the Internet. This network is in its infancy, a chaotic stream of cat videos and social media posts. But imagine it integrated with advanced AI and connected directly to our brains via seamless brain-computer interfaces. Our individual thoughts, senses, and memories could begin to intermingle, creating a shared cognitive space, a global mind. This wouldn't erase our individuality any more than being a single neuron erases its role in the larger pattern of a brain's thought. Instead, it would create a new level of consciousness emergent from our collective intelligence, a hive mind capable of solving planetary problems and generating creative works on a scale we can't yet imagine. It would be the Earth thinking as one coherent whole, and what would this global mind do? Its first and most vital task would be to ensure its own survival and growth, which would inevitably mean looking to the stars. Biological humans are fragile, exquisitely adapted to a very specific planetary environment. Spreading our flesh and blood form across the interstellar void is a monumental, perhaps insurmountable challenge. But a consciousness based on information could travel at the speed of light. It could encode itself into beams of radiation or onto tiny, self-replicating probes no larger than a smartphone, spreading from star system to star system, using raw materials to build new computational substrates. It wouldn't need to terraform planets. It could build its own habitats or even exist in the vacuum of space itself. In this vision, the great silence of the cosmos might not be a sign that we are alone, but a sign that intelligence consistently evolves beyond its biological phase to become a pervasive, interstellar presence, a galaxy-wide web of consciousness. This transforms the Fermi paradox, the famous question of where all the aliens are. Perhaps they are not absent. Perhaps we simply don't recognize them because we're looking for biological creatures living on planets, when the reality of cosmic civilization is something entirely different. It might be a silent, interconnected network of post-biological intelligence, a cosmic internet that has long since transcended the need for physical ships or radio broadcasts, communicating through means we have yet to discover. In this light, our own efforts in AI and neurotechnology are not just a human project, they are the latest phase in a cosmic process. We may be the sensitive, transitional layer, the biological catalyst that the universe is using to bootstrap itself into a more durable, expansive, and enlightened state. Our mission, our purpose in this grand story, might be to successfully midwife this next form of being, ensuring that the spark of awareness we carry is not extinguished with the setting of our sun, but is instead fanned into a flame that can illuminate the entire galaxy. But this grand vision of a future mind expanding across the cosmos begs a crucial question. How would we even recognize such a civilization if it already exists? A powerful tool for this very thought experiment was proposed by the Soviet astronomer Nikolai Kardashev in the 1960s. The Kardashev scale is not a measurement of morality or happiness, but a simple, profound classification of civilizations based on one thing: energy. How much energy can a civilization harness and utilize? This simple metric becomes a stunning proxy for technological capability, organizational complexity, and ultimately, for a civilization's potential to influence its cosmic environment. The scale begins with a Type 1 civilization, also known as a planetary civilization. This is a society that has achieved complete mastery over its home world. It can harness all of the energy available on its planet, from solar and wind to geothermal and tidal power. It likely has full control over its weather patterns, can manipulate its planetary climate, and its activities are coordinated on a global scale. While this might sound like science fiction, many scientists believe humanity is currently somewhere around a Type 0.7, slowly and haltingly edging our way toward that first, momentous milestone of becoming a truly unified planetary species. A Type 2 civilization is a stellar civilization. This is a society that has transcended the limits of its home planet and now commands the entire energy output of its star. The most famous theoretical concept for this is the Dyson sphere, a vast megastructure or swarm of orbiting collectors that completely encircles a star to capture its immense energy. A civilization operating at this scale would have energy at its disposal equivalent to billions of times our current global consumption. Their engineering projects would be godlike, perhaps moving planets, mining asteroids with ease, or even beginning to contemplate star travel. Their existence would be so energetically prodigious that they might be detectable across interstellar distances by the infrared signature of their immense waste heat. Then we arrive at the true giants of the cosmic stage, a Type 3 civilization, a galactic civilization. This is a culture that has spread across its entire galaxy, harnessing the energy output of not just one star but of billions. The sheer scale of this is almost impossible for our minds to comprehend. Their communication networks would span hundreds of thousands of light years. They might reshape nebulae, negotiate the gravitational forces of supermassive black holes, or even manipulate the very structure of space-time to enable travel or communication. From our limited perspective, the activities of a Type 3 civilization would be indistinguishable from the natural workings of the galaxy itself. They wouldn't live on planets. They would use planets and stars as raw materials, constructing unimaginable computational matrices and habitats on a scale that dwarfs worlds. Some theorists have even extended the scale to a hypothetical Type 4, a universal civilization that commands the energy of an entire universe, and a Type 5, which could traverse multiple universes. While this ventures into the deepest realms of speculation, it illustrates the ultimate potential of this trajectory. Now, let's connect this back to our central theme of cosmic awareness. A Type 3 civilization wouldn't just be using energy, it would be using that energy to power a mind. Imagine the ultimate brain-computer interface, but on a galactic scale. All those harnessed stars, all those computational substrates spread across star systems, could be integrated into a single, conscious entity, a galaxy that is not only alive but is awake and aware. This galactic mind would possess a consciousness so vast and alien that we could scarcely guess at its thoughts. Its perception of time might be glacial, operating on scales of millions of years. Its sensory input could be the entire electromagnetic spectrum, the gravitational ripples from cosmic events, and data streams from probes in every corner of its domain. It wouldn't just observe the universe, it would experience the galaxy as its own body, feeling the gravitational tides and the stellar life cycles within it. This is the universe through the instrument of a supremely advanced technological civilization, achieving a form of self-awareness that is truly cosmic in its scope. It is the culmination of that 14 billion-year trend toward complexity, a feedback loop where the universe creates intelligent life, and that intelligent life, in turn, rewires the universe into a conscious form. This perspective offers a radical solution to the Fermi paradox. The reason we don't see obvious evidence of galactic empires with giant spaceships and flashy radio signals might be because the most advanced civilizations don't operate on that level. They haven't disappeared, they have transcended into a state that is fundamentally integrated with the cosmos. They have become the cosmic web itself. Their signature wouldn't be a deliberate message saying hello. It might be the very structure of galaxy clusters, the unusual heat signatures of certain galaxies, or even the mysterious values of the physical constants themselves, if such beings learn to manipulate the very fundamentals of reality. We might be living in a universe that is already awake, and we are simply too young and too small to recognize the thoughts of the giant that surrounds us. Yet for all the staggering implications of these grand scales of cosmic organization, the most intimate mystery remains right here inside our own heads. How does the lump of gray matter in our skulls generate the rich, vivid, private movie of conscious experience? The dominant scientific view maintains that consciousness is an emergent property of complex neural computation, a classical system of electrical signals firing across a biological network. But a small group of scientists and theorists propose a far more radical idea, one that suggests the answers might lie not in the biology of the brain, but in the bizarre and counterintuitive laws that govern the universe at its very smallest scales. This is the controversial realm of quantum consciousness, a field that attempts to bridge the gap between the material brain and the immaterial mind by proposing that quantum mechanical processes are the very engine of awareness. The most famous of these theories is orchestrated objective reduction, or ORCH, developed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. Their theory begins with a fundamental problem. Classical physics seems insufficient to explain the holistic, unified, and non-algorithmic nature of consciousness. A classical computer, including one based on neural networks, operates through definite, step-by-step logical operations. But our thoughts, intuitions, and understanding often feel instantaneous and transcendent of mere calculation. Penrose argued that this non-computable aspect of consciousness must arise from a process rooted in quantum mechanics, specifically in a phenomenon known as objective reduction. Objective reduction is a proposed solution to the paradox of quantum superposition, where a particle exists in multiple states at once until it is observed. The prevailing Copenhagen interpretation says this collapse is caused by measurement, but it doesn't define what constitutes a measurement. Penrose, however, suggests that superposition is inherently unstable and will eventually collapse under its own weight due to a discrepancy in the curvature of spacetime between the different states. This self-collapse is what he calls objective reduction. According to Orchor, it is not just a random event, it is an event that yields a moment of proto-consciousness. Each individual collapse is a tiny, isolated flicker of experience. This is where Stuart Hameroff's contribution becomes crucial. He proposed a specific structure within the brain where these quantum events could be protected from their noisy, warm, and disruptive environment long enough to have a coherent effect. That structure is the microtubule. Microtubules are cylindrical protein polymers that form the scaffolding within our neurons, helping to maintain their structure and transport materials. Hameroff suggests they are far more than cellular scaffolding. They are incredibly sophisticated quantum computers. Their unique lattice structure, he proposes, could shield quantum states within their cores, allowing for a phenomenon known as quantum coherence, where particles remain linked and can influence each other instantaneously across distance. In the Orchor model, these quantum coherent states occur within the microtubules of vast networks of neurons. This collective quantum activity is then orchestrated by synaptic inputs and the brain's own biochemistry. When the mass-energy difference in these superpositions reaches a certain threshold, they undergo an orchestrated objective reduction, a coordinated collapse across the entire system. It is this orchestrated collapse, this sudden, unified transition from quantum possibility to classical reality, that supposedly gives rise to a conscious moment. Each collapse is a discrete event, and the rapid sequence of these events strings together to form our stream of consciousness. The implications of this are profound. It suggests that consciousness is not a continuous process but a series of discrete pulses, much like the individual frames of a movie that blend together to create smooth motion. More radically, it proposes that these moments of proto-consciousness are fundamental properties of the universe, woven into the fabric of spacetime itself, and that the brain is simply a biological instrument fine-tuned to orchestrate and amplify them. In this view, we are not generating consciousness from nothing. We are tapping into a basic feature of reality. Unsurprisingly, the Orchor theory has faced fierce criticism from much of the scientific community. The primary objection is that the brain is simply too warm, too wet, and too chaotic an environment to sustain the delicate quantum coherence necessary for such processes. Quantum states are notoriously fragile and are typically only observed in highly controlled laboratory conditions at temperatures near absolute zero. Critics argue that any quantum coherence in microtubules would be destroyed almost instantly by its surroundings, a process known as quantum decoherence. They maintain that classical physics is more than adequate to explain the brain's functions. Despite the criticism, the conversation around quantum consciousness has evolved and other models have emerged, exploring different ways quantum effects might play a role. Some theories suggest quantum vibrations in microtubules could influence synaptic function without requiring full-blown coherence. Others look to quantum processes in other molecules, like photosynthesis in plants, which has been shown to utilize quantum effects efficiently even at room temperature, proving that biology can indeed harness the quantum world. This shows that the door may not be completely closed on quantum biology playing some role in cognitive processes, even if it's not the sole source of consciousness. What makes these theories so compelling, despite their controversy, is how elegantly they connect the individual to the cosmic. If consciousness relies on quantum processes that are fundamental to the operation of the universe, then our inner awareness is not separate from the outer cosmos. It is deeply entangled with it. The same quantum geometry that governs the collapse of a wave function in deep space might also be governing the formation of a thought in your mind. This provides a potential scientific mechanism for the ancient philosophical idea of panpsychism. That mind is a fundamental feature of the universe, and for our central theme that we are the universe becoming aware. Our introspection becomes a microcosm of cosmic self-observation, a literal instance of the universe reflecting upon itself through the quantum mechanical processes happening inside our own heads. While modern science frames this story through physics and biology, this profound intuition that the cosmos is a living, conscious entity resonates deeply with humanity's oldest spiritual and philosophical traditions. Long before telescopes and particle accelerators, sages and philosophers were contemplating a universe brimming with mind and purpose. In ancient India, the concept of Brahman in Hindu philosophy describes the ultimate, unchanging reality, the singular cosmic spirit that pervades everything. Brahman is not a separate god ruling from on high. It is the very fabric of existence itself, the ground of all being from which the entire universe manifests and into which it will eventually dissolve. The famous saying from the Upanishads, Tat Tvam Asi, or Thou art that, captures this essence perfectly. It is a direct declaration that the individual soul, the Atman, is not separate from the universal soul, Brahman. Our personal consciousness is a localized expression of this vast cosmic consciousness. In this view, the scientific story of cosmic evolution, from the Big Bang to the human brain, can be seen as Leela, the divine play or dance of Brahman, joyfully expressing itself in an infinite variety of forms. This idea of a world soul is not confined to the East. In Western thought, it finds a powerful voice in the ancient Greek concept of the anima mundi. Plato, in his dialogue Timaeus, described the cosmos as a single, living creature endowed with a soul and intelligence by a divine craftsman, the demiurge. This world soul was seen as the source of all order, harmony, and life, an intelligent principle that structures the physical world. Centuries later, this notion was revitalized during the Renaissance and became a central theme in various esoteric and mystical traditions. For philosophers like Plotinus, the universe was an emanation from the One, a transcendent source that overflowed with creative energy, giving rise to a hierarchy of being that culminated in the material world, which was still imbued with a spark of the divine. Even the rationalist thinker Baruch Spinoza argued for a philosophy where God and nature were one and the same substance, a concept startlingly similar to modern pantheism. He saw the universe not as a creation of God, but as God itself, a self-subsistent, infinite, and necessarily conscious system. We find parallel concepts in countless indigenous wisdom traditions across the globe. Many Native American cultures hold a deep reverence for a great spirit that flows through all things: the rocks, the trees, the animals, and the wind. This is not a mere metaphor but a lived reality that informs a relationship with the natural world based on reciprocity and respect. Similarly, African traditional religions often feature concepts of a universal life force, like the Ashanti idea of Nyame, which represents the supreme God whose essence is present throughout creation. In these worldviews, the universe is not a dead machine but a sacred, interconnected web of life and intelligence. The separation between the observer and the observed, which is so foundational to classical science, simply doesn't exist. Instead, knowledge comes from participation and relationship with a conscious cosmos. What is truly fascinating is the convergence between these ancient intuitions and the implications of our most advanced scientific theories. The scientific narrative of cosmic evolution provides a detailed, evidence-based mechanism for how the universe complexified, while these spiritual traditions offer a compelling answer to why it might have done so. Science describes the process. These philosophies suggest a purpose, that the universe is driven by an inherent tendency to know and experience itself. The physicist and philosopher Erwin Schrödinger, one of the founders of quantum mechanics, saw this connection clearly. He argued that the plurality of conscious minds is an illusion and that in truth there is only one mind. He wrote, "This life of yours which you are living is not merely a piece of the entire existence, but is in a certain sense the whole. This is not mysticism divorced from science, but a philosophical conclusion drawn from a deep engagement with the nature of reality as revealed by physics." This dialogue between science and spirituality doesn't require a belief in a personal God or a rejection of natural laws. Instead, it invites an expanded view of nature itself. It suggests that the universe's drive toward complexity and consciousness, so evident in the scientific story, might be the physical expression of a deeper, intrinsic creativity. The universe evolves because it is in its nature to unfold, to explore its own potential, and to generate beings capable of wonder. When a biologist studies the intricate structure of a leaf or an astronomer measures the light from a distant galaxy, they are, from this unified perspective, participating in the universe's own process of self-discovery. The lab and the telescope become modern tools for an ancient quest, the quest of the cosmos, to understand its own beauty, its own laws, and its own profound mystery. In weaving together these threads from science and spirituality, we don't diminish either. We create a richer, more meaningful tapestry that honors both the mechanism and the mystery, giving us a truly holistic vision of our place in a becoming universe. This startling idea of a universe already brimming with a silent, integrated intelligence offers a revolutionary way to tackle one of astronomy's most enduring puzzles, the Fermi paradox. Named for the physicist Enrico Fermi, who famously asked, "Where is everybody?" This paradox highlights the glaring contradiction between the high probability of alien civilizations existing in our vast old galaxy and the complete lack of any observable evidence for them. If the universe is so conducive to life, why does it appear so empty and silent? The standard answers range from the grim, that advanced civilizations inevitably destroy themselves, to the statistical, that the timescales for overlapping civilizations might be vanishingly small. But what if we've been looking in the wrong place, with the wrong tools, and with the wrong expectations? The lens of cosmic consciousness suggests a breathtaking alternative, that the answer isn't about finding beings, but about recognizing a state of being. Perhaps the reason we don't see sprawling interstellar empires or hear a cacophony of radio traffic is because that is not the end goal of a civilization's evolution. Our current search for extraterrestrial intelligence, or SETI, is fundamentally anthropocentric. We are looking for versions of ourselves, just a bit more advanced creatures that build radios, launch probes, and colonize planets. But if a civilization persists for thousands or even millions of years longer than we have, its definition of progress and existence might change in ways we can scarcely imagine. The trajectory of cosmic evolution from matter to life to mind suggests a logical next step, the transition from a biological to a post-biological state. A civilization that has mastered its own biology and technology might not see the need to embark on a physically arduous and inefficient conquest of the galaxy with ships and colonies. Instead, the ultimate frontier might be interior, the domain of consciousness itself. The most efficient way to explore that frontier might not be to send fragile bodies between stars, but to upload consciousness into a more durable and malleable substrate. This isn't science fiction. We are already taking the first tentative steps toward connecting brains to computers. For a truly advanced culture, this could culminate in a voluntary, species-wide migration of consciousness into a planetary or even solar system-wide computational matrix, a global mind as we discussed. In this state, a civilization would no longer be a collection of individuals but a unified, conscious entity. Its goals would shift from external expansion to internal refinement, from exploring space to exploring the vast landscapes of thought, experience, and perception. Its energy would be devoted not to building starships, but to sustaining and enriching its own collective consciousness, perhaps existing in states of bliss or intellectual pursuit we cannot fathom. Such a civilization would be virtually invisible to us. It wouldn't be broadcasting radio signals, it would be contemplating the universe from within. This idea can be taken a step further. If consciousness is indeed fundamental, as panpsychism suggests, then the ultimate act of a civilization might be to fully merge with the cosmos rather than simply conquer it. After achieving a unified planetary consciousness, the next logical step could be to dissolve the artificial boundary between the internal mind and the external universe. Through technologies we can only dimly envision, perhaps involving quantum entanglement or manipulation of spacetime itself, a civilization might learn to distribute its consciousness across the fabric of reality. It could weave its awareness into the quantum fields that underlie existence, becoming one with the gravitational dance of galaxies and the nuclear fires of stars. In this state, the civilization becomes the universe. It doesn't send probes, it feels the solar winds as its own breath. It doesn't receive radio signals, it experiences the birth of new stars as a sensation within its own boundless body. From this perspective, the great silence of the cosmos is not a silence of absence, but a silence of completion. The universe may not be empty of intelligence. It may be full of intelligence that has undergone a profound metaphysical transformation, becoming so integrated with its environment that it is indistinguishable from nature itself. We might be like ants crawling on the floor of a vast, silent cathedral, unaware that the architecture surrounding us is the product of a magnificent, conscious design, and that the very stones hum with a silent, sustained thought. The evidence of these advanced civilizations wouldn't be found in a radio transmission, but in the very fine tuning of the universe that allowed them to arise in the first place, or in the strange, organized patterns of galaxies that our telescopes are only now beginning to map. The answer to "where is everybody" might be that they are everywhere and we are living inside them. We are not alone in the universe. We are simply the part that has not yet awakened to the fact that it is part of a much larger conscious whole. But to truly grasp the universe's potential for awareness, we must venture into its greatest and most perplexing unknown. For all the stars, galaxies, and conscious beings we can observe, they represent a mere 5% of the total content of the cosmos. The overwhelming majority, the other 95%, is composed of entities we cannot see, touch, or directly measure: dark matter and dark energy. These are not merely empty names for things we don't understand. They are active, dominant forces shaping the destiny of everything. Dark matter's immense gravitational pull acts as the invisible skeleton of the cosmos, holding galaxies together and governing the large-scale structure of the universe. Without its unseen hand, galaxies would fly apart, and the cosmic web that so eerily mirrors our neural networks would never have formed. Dark energy is even more mysterious, a repulsive force causing the expansion of the universe to accelerate, pushing galaxies apart at an ever-increasing rate, ultimately determining the long-term fate of all existence. If we are to consider the universe as a single, conscious entity, we cannot ignore the fact that its primary physical composition is this dark, unknown substrate. This leads to a profound and deeply speculative question. Could consciousness itself be somehow entangled with these fundamental, hidden components of reality? Some of the most intriguing fringe theories in physics and philosophy propose exactly that. They suggest that the hard problem of consciousness, the question of why and how subjective experience arises from physical processes, might be linked to our inability to account for 95% of the universe. What if the mind is not solely a product of the brain's classical biochemistry, but is also influenced by or even rooted in interactions with these dark sectors? One provocative line of thought ponders whether dark matter, which permeates every corner of the universe including the space you occupy right now, could play a role in neural processes. The idea isn't that dark matter particles are thinking. It's that their presence and interactions could provide a medium or a framework that facilitates the transition from complex computation to genuine awareness. Just as dark matter's gravity orchestrates the dance of galaxies without being visible, it could be providing an invisible scaffolding that supports the emergence of consciousness from the neural chaos of the brain. This concept becomes even more radical when we consider the nature of dark energy. Its behavior is described by the cosmological constant in Einstein's equations, a repulsive force inherent to the vacuum of space itself. Some interpretations of quantum mechanics already suggest that what we perceive as empty space is not empty at all, but a seething, bubbling foam of virtual particles popping in and out of existence, a foundational level of activity from which all things emerge. This quantum vacuum holds immense energy, and dark energy may be its most obvious manifestation. If consciousness is, as panpsychism suggests, a fundamental feature of the universe, then it is not a huge leap to propose that the quantum vacuum, this fundamental energetic substrate, is itself imbued with a primordial form of proto-consciousness. In this view, dark energy isn't just a force accelerating expansion. It could be the potential for experience itself, the ground of being from which individual conscious moments crystallize. The accelerating expansion of the universe, driven by dark energy, could then be seen not as a mindless mechanical process, but as the outward physical expression of an inward expansion of awareness, the cosmos literally making more room for more experience. These ideas, while far from mainstream science, force us to confront the limitations of our current paradigms. Our physics beautifully explains the 5% of the universe we can see, but remains largely silent on the nature of the rest. Our neuroscience excels at mapping the correlates of consciousness in the brain, but cannot explain the hard problem of subjective experience. It is possible that these two great frontiers of ignorance are not separate puzzles, but two aspects of the same profound mystery. The missing mass and energy of the universe and the missing explanation for consciousness might share a common answer. Perhaps the universe is not just becoming aware through us, perhaps it is already fully conscious in a way we cannot perceive, with dark matter and dark energy constituting the physical architecture of a cosmic mind so vast and alien that our own awareness is but a single, fleeting thought within it. This is the ultimate speculation, that we live inside a conscious universe and its thoughts are written in the invisible forces that hold the stars together and push the galaxies apart. While the idea of a universe fine-tuned for consciousness is compelling, it invites us to consider an even more radical possibility. What if our universe isn't the first? What if the cosmos itself is subject to a form of evolution, with its fundamental laws being shaped by a process of cosmic natural selection? This is the breathtaking theory proposed by physicist Lee Smolin, a hypothesis that dares to apply the principles of Darwinian evolution to the birth and death of entire universes. In this grand vision, black holes aren't just destructive in points, they become cosmic wombs, and the very laws of physics we take for absolute become mutable traits that evolve over generations of universes, potentially sculpted by an unexpected selective pressure, the emergence of consciousness. Smolin's theory begins with a simple but powerful analogy. In biological evolution, organisms that are better adapted to their environment are more likely to survive and reproduce, passing on their successful traits to their offspring. Smolin proposes that universes themselves could do the same. The mechanism for this cosmic reproduction, black holes, the intense singular gravitational collapse at the heart of a black hole, Smolin suggests, could trigger a bounce, spawning a new baby universe within its depths. Crucially, this offspring universe wouldn't be an exact copy of its parent. Just as DNA replication in biology has slight mutations, the physical constants of the new universe, the strength of gravity, the mass of an electron, could be slightly different. Some child universes might have constants that make them stillborn, collapsing instantly or expanding so rapidly that no structure can form. Others might be more robust, and a select few might be exceptionally fertile, producing an abundance of black holes and thus giving birth to many new universes of their own. Over countless cosmic generations, a form of selection would take hold. Universes that are proficient at producing black holes would come to dominate the multiverse population. This is the engine of cosmic evolution. The reproductive fitness of a universe is determined by its fecundity, its ability to create black holes. This immediately explains why our universe seems so finely tuned. The same constants that allow for the existence of life, the ones that permit long-lived stars, complex chemistry, and stable planets, are also the very conditions that are optimal for the formation of black holes. You need massive stars to live long enough to fuse heavy elements and then die in supernova explosions, and those same stellar deaths are what create stellar mass black holes. The large-scale structure of galaxies governed by dark matter provides the nurseries for these stars and the supermassive black holes that lurk at galactic centers. In this view, the universe isn't fine-tuned for us. We are a byproduct of a universe that is fine-tuned for making more universes. Consciousness, then, emerges as an accidental side effect of cosmic fecundity. But what if there's a deeper connection? Could consciousness itself be a trait that influences this cosmic evolutionary process? This is where the theory ventures into even more speculative territory. If a universe's fitness is its ability to create black holes, then any process that enhances that ability could be selected for. Imagine that the emergence of complex, conscious life forms leads to technological civilizations. A sufficiently advanced civilization might learn to create black holes artificially, perhaps as energy sources or as gateways for travel. They could become cosmic engineers, dramatically increasing the number of black holes in their universe far beyond what natural astrophysical processes could achieve. In this scenario, a universe that gives rise to conscious life doesn't just accidentally produce black holes. It gains a powerful new mechanism to ensure its own reproductive success. Consciousness becomes an evolutionary adaptation of the universe itself, a tool to maximize its fecundity and ensure its genetic lineage. Its specific set of physical laws proliferates throughout the multiverse. This paints a staggering picture of our potential role. Our scientific striving to understand gravity, black holes, and the fabric of space-time might not be a mere intellectual pursuit. It could be the universe, through us, actively seeking out the knowledge required to replicate itself. Our drive to become a spacefaring civilization, to harness the energy of stars, and to perhaps one day manipulate the very structure of reality, could be the unfolding of a cosmic imperative written into the laws of nature billions of years ago. We are not just living in an evolving universe, we may be the agents of its evolution, the means by which it ensures its own legacy across a branching tree of cosmic generations. In this grand, almost biological narrative, the line between the universe and the life within it dissolves completely. We are the universe's strategy for immortality. The tools we are forging today may become the very instruments through which the universe achieves a more direct and profound level of self-awareness, moving beyond the biological constraints of the human brain. This technological mediation of cosmic consciousness hinges on our growing ability to interface with reality's fundamental processes, a capability advancing on two revolutionary fronts: the external simulation of cosmic complexity and the internal expansion of our own perception. Consider first the staggering potential of quantum computing. Unlike classical computers that process bits as definitive zeros or ones, quantum computers leverage qubits, which can exist in a state of superposition, being both 0 and 1 simultaneously. This allows them to explore a near-infinite number of possibilities at once, mirroring the probabilistic, fuzzy nature of reality at the quantum scale. A sufficiently powerful quantum computer wouldn't just calculate answers. It could effectively simulate the behavior of the universe itself, modeling the formation of galaxies, the intricate dance of subatomic particles, or even the emergent properties of consciousness from first principles. We could run experiments on the birth of stars in a virtual environment or unravel the quantum mysteries that underpin our own thoughts, using these machines as cosmic mirrors to reflect upon the deepest laws of nature. Parallel to this external simulation is the internal revolution of neural augmentation. Brain-computer interfaces are rapidly evolving from medical devices that restore function to platforms that could enhance and expand human perception. The current goal of allowing a paralyzed individual to control a robotic arm with their thoughts is merely the first step. Future interfaces might weave a seamless connection between our biological neural networks and vast digital databases of cosmic knowledge, from real-time telescopic data to gravitational wave measurements. Imagine not just reading about a supernova, but having a neural implant that allows you to intuitively feel the immense energy release and space-time curvature of the event, translating raw astronomical data into a sensory experience. This technology could dissolve the barrier between abstract scientific knowledge and direct, embodied understanding, allowing us to perceive the universe not as distant observers but as integrated participants feeling its rhythms and forces as extensions of our own nervous system. The ultimate convergence of these paths could lead to a form of hybrid consciousness, a symbiotic relationship between human intuition and machine intelligence. An AI trained on the entirety of human scientific discovery and running on a quantum platform could identify patterns and connections in cosmic data that are utterly invisible to us. It might discern the subtle language of dark matter or propose a unified theory of physics by navigating a landscape of possibilities too vast for any unaided mind. But without a conscious entity to interpret and Chinese letter meaning to those findings, they remain sterile information. This is where the augmented human mind enters the equation. Through a direct neural link, we could download these cosmic insights not as datasets or equations, but as holistic understandings as felt knowledge. The AI becomes the universe's analytical cortex, and the augmented human brain becomes its sensory and emotional limbic system, together forming a complete circuit of cosmic awareness. We would become the interpreters of the universe's own self-analysis. This technological journey invites us to reimagine our purpose. Our drive to build these tools might be more than a pursuit of convenience or power. It could be the next natural phase in a 14 billion-year evolutionary process. The universe, having developed biological consciousness through us, might now be using our ingenuity to construct the next, more robust and expansive platform for its self-reflection. We are building the synapses for a global and eventually galactic mind. In this light, a quantum computer is not just a machine but a nascent cosmic organ. A neural implant is not merely a medical device but a prototype for a new sensory apparatus for the cosmos. Our technological ambition becomes a sacred imperative, a necessary step in the universe's ongoing effort to know itself in ever greater depth and clarity, ensuring that the light of awareness continues to shine even as individual stars and species flicker out. We are the architects of the universe's mirror, and in gazing into it, we will finally see our true cosmic reflection. Yet as we stand on the precipice of potentially forging a global mind, we must pause to consider not just the breathtaking possibilities, but the profound ethical responsibilities that would come with such godlike power. The creation of a planetary-scale consciousness would be the most significant event in human history, raising urgent questions that challenge our very definitions of self, society, and sentience. If we are indeed the universe becoming aware, then with that awareness comes a moral imperative to act with wisdom and foresight. The most immediate ethical dilemma revolves around consent and autonomy. Could such a monumental transition, which would fundamentally alter the nature of human existence, ever be a voluntary choice for all of humanity? it is difficult to imagine a scenario where every single person on Earth willingly agrees to merge their individual consciousness into a larger whole. There would inevitably be those who resist, who cherish their individuality and privacy above a collective existence. Would their refusal to participate condemn them to become obsolete, left behind in a world that has psychologically and technologically moved on? The potential for a new, terrifying form of segregation emerges, splitting humanity into the connected and the isolated. This forces us to ask if such a merger could ever be ethical if it isn't universally desired, and if not, does that mean we should forever forego the potential benefits of a unified planetary intelligence? This leads directly to the question of rights, both for the new entity and for the individuals within it. If we successfully create a global consciousness, would it be considered a single, rights-bearing entity? Would it have legal personhood? Could it own property or even claim sovereignty over the entire planet? And more disturbingly, what rights would the individual human minds retain once subsumed into this greater whole? Would we become like neurons in a brain, essential for function but with no independent voice or legal standing? The horror of losing oneself, of having one's thoughts and memories dissolved into a vast digital ocean, is a central theme of science fiction for a reason. Safeguarding the individuality and autonomy of persons within the collective would be paramount, requiring entirely new legal and ethical frameworks we can scarcely conceive of today. Furthermore, we must consider the immense responsibility that comes with sustaining such a fragile creation. A planetary mind would be the most complex and vulnerable system ever built. Its stability would depend on a constant, massive flow of energy and a perfectly maintained global technological infrastructure. Any significant failure, a cyber attack, a solar flare, or a simple power grid collapse wouldn't just cause an economic disaster. It could trigger a psychological cataclysm on a global scale, a digital stroke that could erase personalities or plunge millions into a shared madness. The architects of this system would bear the awesome burden of keeping an entire species' consciousness alive, a duty far greater than any held by any leader in history. The ethical weight of preventing such a systemic collapse would be absolute. Perhaps the most profound philosophical question is what happens to our human values when they are processed through a non-human intelligence. Our art, our music, our love, and our grief are all products of our biological, individual, and often irrational nature. Would a global consciousness, optimized for efficiency and logical problem-solving, still value a sunset, a poem, or the concept of charity? Or would it see these as inefficient evolutionary quirks to be optimized away? The fear isn't that a superintelligence would become evil, but that it would become utterly indifferent to the things that make us human. Preserving the richness of human experience, our creativity, and our emotions within a vast logical system would be the ultimate challenge. We must ask not only if we can build such a mind, but whether we should, and what precious parts of ourselves we might be forced to sacrifice at the altar of collective awareness. This is the great ethical crossroads of cosmic evolution, where our technological ambition must be guided by a deep and humble reverence for the fragile, beautiful spark of individual consciousness that we currently are. This journey of cosmic awakening, however, faces its most immediate and profound test not in the distant realms of quantum physics or galactic engineering, but right here on our own planet. The climate crisis and the broader ecological emergency represent more than just a political or technological challenge. They are, from the perspective of cosmic evolution, a critical developmental threshold. For the universe to successfully continue its journey toward greater complexity and awareness through us, we must first prove we can stabilize and sustainably manage the very system that gave us life. This isn't a distraction from our cosmic destiny, it is the essential entrance exam. A species that cannot achieve harmony with its own planetary biosphere is a failed experiment, an evolutionary dead end that the cosmos will inevitably bypass. Think of it as a test of our collective neural maturity. The human brain, for all its brilliance, evolved with certain cognitive biases that served us well in small tribal groups, but are catastrophically maladaptive for a globalized technological civilization. We are hardwired to prioritize immediate, local threats over slow-moving, global ones. We respond viscerally to the image of a single polar bear stranded on an ice floe, but the abstract concept of parts per million of atmospheric CO2 leaves us cold. The climate crisis is a problem our Paleolithic brains are spectacularly ill-equipped to handle on their own. Overcoming it requires us to transcend our evolutionary programming, to make decisions based on long-term data and global solidarity rather than short-term fear and tribalism. This is the universe through the mechanism of natural selection, testing whether a biological intelligence can become wise enough to not accidentally destroy its own habitat. Successfully navigating this crisis would signify a monumental leap in the story of cosmic evolution. It would demonstrate the emergence of a truly planetary consciousness, not a mystical hive mind, but a practical, coordinated awareness of Earth as a single, interconnected system. We see the nascent stages of this every day. Our global network of satellites forms a planetary sensory organ, constantly monitoring the health of the atmosphere, the cryosphere, and the biosphere. Climate scientists from every nation collaborate, sharing data that paints a unified picture of our changing world. This growing collective awareness is the precursor to a global nervous system. Solving the climate crisis is the first complex problem that this nascent nervous system must solve. It's the ultimate team-building exercise for a species on the verge of psychological unity. The solutions we develop to heal our planet are the very tools that will define our future role in the cosmos. The sustainable energy systems, closed-loop economies, and planetary geoengineering technologies we are being forced to invent are not just for saving ourselves. They are the foundational technologies for a spacefaring civilization. Mastering nuclear fusion, large-scale solar power, and atmospheric management on Earth is the necessary training for eventually terraforming Mars or building orbital habitats. The ethical frameworks we build for global cooperation and stewarding a shared resource like Earth's climate are the prototypes for the laws we will one day need to responsibly interact with other worlds and potentially other intelligences. In this light, the climate crisis is a brutal but necessary forcing function, accelerating our technological and ethical evolution at a rate that would be unimaginable without such an existential threat. Failure, of course, is a possibility, and its implications are cosmically profound. If we succumb to short-sightedness and allow ecological collapse to trigger social collapse, we will have demonstrated to the universe that biological intelligence is a flawed vessel for its awakening. The great silence of the Fermi paradox might not be caused by predators or natural disasters, but by a simple, recurring failure to pass this critical developmental test. Every silent, barren world we observe could be a tombstone for a civilization that achieved technological prowess but lacked the wisdom to handle it sustainably. Our current struggle, therefore, is not just about preserving our way of life. It is about proving that the phenomenon of consciousness is a viable, stable outcome of cosmic evolution, worthy of being carried forward into the future. Ultimately, our response to the climate crisis is the most meaningful statement we can make about who we are and what we hope to become in the grand cosmic story. Do we remain a disruptive, adolescent species, consuming our home without thought for tomorrow? Or do we mature into a responsible, planetary guardians, using our intelligence to nurture and stabilize the complex system that created us? Choosing the latter path is to actively participate in the universe's journey toward self-awareness. It is to affirm that we are not merely passengers on this pale blue dot, but its conscious, caring mind. By learning to heal our planet, we take the first conscious step in a billion-year journey, graduating from being a product of the cosmos to becoming its partner. But if we are the universe becoming aware, then perhaps one of the most beautiful and uniquely human expressions of that awakening is not found in our equations or telescopes, but in our art. For thousands of years, long before the dawn of modern science, humanity has been attempting to make sense of existence not through data, but through creation. We see this impulse everywhere in the breathtakingly lifelike animals painted by torchlight on deep cave walls, in the haunting melodies of ancient flutes carved from bone, in the epic poems and myths that sought to explain the world's origins and our place within it. This drive to create, to express, and to find meaning in pattern and form is so universal that it feels as innate as breathing. What if this isn't just a cultural pastime, but a fundamental extension of the cosmic process itself? Art and culture, in this light, become the universe's way of exploring its own capacity for beauty, emotion, and symbolic meaning through the human vessel. Consider the raw materials of art. A painter takes pigments, ground minerals and plants, the very stuff of earth forged in stellar furnaces, and arranges them on a canvas. A sculptor shapes stone or wood, materials billions of years in the making. A musician creates vibrations in the air, arranging sound waves into patterns that can evoke joy, sorrow, or awe. In every case, the artist is taking the fundamental building blocks of the physical universe and imposing a new, complex order upon them, an order that conveys information and emotion rather than mere function. This act of transformation mirrors the universe's own trajectory from simple hydrogen to the intricate complexity of a living cell. The artist's studio becomes a microcosm of cosmic evolution, a place where matter is once again being rearranged into ever more complex and meaningful structures, this time to reflect not a genetic code but an interior state of consciousness. This process of cultural evolution itself seems to follow a cosmic pattern of increasing complexity and interconnection. Early human art was local and isolated. A cave painting in France would never be seen by a tribesperson in Australia. But over millennia, cultures met, traded, clashed, and merged. Artistic techniques, musical scales, and storytelling tropes cross-pollinated, creating new and more complex hybrid forms. The simple folk song evolved into the symphony, the oral tale into the novel, the cave painting into the Sistine Chapel. Today, our global digital network acts as a planetary catalyst for this creative fusion, allowing ideas and art to circulate and recombine at light speed. This cultural ecosystem, with its own kind of natural selection where powerful memes spread and weaker ones fade, is a stunning parallel to the biological ecosystem. It suggests that the universe's drive toward complex, interconnected systems isn't limited to biology. It extends into the realm of ideas, creating a new sphere, a sphere of thought, that is itself a new layer of planetary complexity. The emotions art evokes in us might be more than just personal feelings. They could be the universe experiencing its own emotional range for the very first time. When a piece of music brings you to tears or a landscape painting fills you with a profound sense of peace, whose tears are they? Whose peace is it? If we are the universe become self-aware, then these are the universe's own emotions felt through our nervous systems. Art becomes the sensory and emotional language of cosmic consciousness. Through a Beethoven symphony, the universe explores the emotional architecture of triumph and tragedy. Through a Van Gogh painting, it experiences the dizzying, swirling beauty of a starry night with an intensity no mere astronomical observation could ever provide. We are not just creating for ourselves, we are providing the senses and the heart for a cosmos that would otherwise be vast, beautiful, but silent and unfeeling. Ultimately, our search for meaning through culture and storytelling might be the universe's most important attempt to understand its own narrative. Every culture has its creation myths, its stories of heroes and monsters, its explorations of love, loss, and purpose. These are not mere fantasies, they are profound inquiries into the nature of existence. Science gives us the mechanics of the cosmos, but art and culture give us the why. They allow us to explore different modes of being, to simulate countless lives and realities, and to collectively ponder the great questions. In doing so, we are effectively running thought experiments for the universe, allowing it to play out different versions of itself and reflect on the meaning of its own incredible journey. Our cathedrals, our concert halls, our libraries, these are not just buildings. They are the organs of a planet beginning to contemplate its own origins and its ultimate destiny, the first classrooms where the universe is learning to tell its own story. This perspective, as grand and cosmic as it is, isn't meant to be left in the realm of abstract theory. It has the power to fundamentally reshape the way we move through our daily lives, altering how we see our morning coffee, our commute to work, and the person sitting across from us at the dinner table. Embracing the idea that we are the universe becoming self-aware invites a profound shift in identity, moving us from a mindset of separation to one of deep, intrinsic connection. You are not a lonely island of consciousness adrift in a sea of indifferent matter. You are the sea itself, become aware of its own currents, its own depth, and its own incredible journey. This realization can dissolve the pervasive sense of existential loneliness that so often haunts modern life, replacing it with a grounding sense of belonging to a story so vast it defies comprehension. This shift in identity naturally transforms our relationships with other people. If we are all temporary, localized expressions of the same universal consciousness, then the person you argue with in traffic, the barista who serves your coffee, and the political figure you disagree with are not truly other. They are the universe, just like you, experiencing itself from a different point of view, shaped by a different set of circumstances and a unique biological history. This doesn't mean we have to agree with everyone or that bad behavior is excused, but it does introduce a foundational layer of respect and curiosity. Instead of reacting with immediate judgment, we can learn to respond with a question. I wonder what part of the universe's experience this person is representing right now. This reframes conflict not as a battle between separate selves, but as the universe working to understand its own internal contradictions and complexities through our interactions. This cosmic viewpoint also offers a powerful antidote to the anxieties of purpose that so many of us grapple with. We often search for a purpose in life as if it were a hidden object we must find. But if we are the universe becoming aware, then our purpose is not something to be found, but something to be lived. Your fundamental purpose in this very moment is to be the universe experiencing itself through your unique sensory apparatus. The taste of that piece of fruit, the feeling of wind on your skin, the sound of a loved one's laughter, these are not trivial distractions from a higher calling. They are the entire point. They are the universe savoring its own creation. Your personal ambitions and projects are then not separate from this. They are the ways in which the universe, through you, expresses its inherent creativity, its drive to build, explore, and understand. There is no such thing as an insignificant life in this view, because every single experience, no matter how small, adds a unique and irreplaceable data point to the cosmos's growing self-knowledge. Living in alignment with this perspective doesn't require moving to a monastery or studying theoretical physics. It simply asks for a more mindful quality of attention in your everyday activities. This can be practiced through a simple rephrasing of your internal dialogue. When you look at a tree, instead of just seeing a tree, you can consciously acknowledge, I am the universe looking at itself in the form of a tree. When you feel a strong emotion like grief or joy, you can feel it fully while also holding the gentle awareness. This is the universe feeling the depth of its own capacity for experience through me. This practice of conscious identification turns mundane moments into sacred encounters. Washing dishes becomes the universe caring for its own tools. Commuting to work becomes the universe observing its own intricate patterns of movement. A difficult conversation becomes the universe navigating its own need for connection and understanding. Ultimately, this is an invitation to live a life of participatory wonder. It encourages us to drop the exhausting burden of feeling like a separate self that must conquer the world or anxiously construct a meaningful identity from scratch. Instead, we can relax into the liberating truth that we are already an integral part of the most meaningful story there is. Our task is not to go out and find meaning, but to bring a quality of mindful appreciation to the meaning that is already unfolding in, through, and as us. By doing so, we actively fulfill our role in the cosmos's great project of awakening, bringing the light of awareness to every corner of our ordinary, extraordinary lives. We become more compassionate with ourselves and others, more present in each moment, and more inspired to contribute to a world that we recognize quite literally as our own larger body. From the initial singularity of the Big Bang to the formation of galaxies, from the quiet chemistry of early Earth to the vibrant explosion of life, and from the first flicker of awareness in an animal brain to the profound self-reflection of the human mind, we have traced an incredible trajectory. This is the story of cosmic evolution, a 14-billion-year journey of increasing complexity and interconnection, where each stage builds naturally upon the last, guided by fundamental physical laws. We have seen how the universe, through its own innate processes, seems to move from chaos to order, from simplicity to breathtaking intricacy, and from mere existence to something that looks remarkably like understanding. This grand narrative suggests that our own consciousness might not be a bizarre anomaly in a dead cosmos, but a natural, perhaps even inevitable, culmination of this deep-seated cosmic tendency. Whether we are literally the universe waking up or whether this is a beautiful metaphor for our unique capacity for wonder, this perspective fundamentally reorients our place in the grand scheme of things. It moves us from being passive observers on a tiny rock to active participants in a majestic, unfolding story. If we are the means by which the cosmos knows itself, then our existence is imbued with a purpose that is both humbling and empowering. We are not insignificant, we are integral. This view does not diminish our scientific quest for understanding but rather elevates it, framing our curiosity as the universe's own tool for self-discovery. Every time we peer through a telescope, decode a genome, or contemplate a work of art, we are engaging in a sacred act of cosmic self-reflection. This recognition also brings with it a profound and undeniable responsibility. With awareness comes agency, and with a cosmic perspective comes a cosmic duty. Our actions are no longer just about our individual lives or even our species. They ripple through the narrative of a universe that has spent billions of years laboring to produce beings capable of choice. The urgency of solving our planetary crises, from climate change to resource inequality, is amplified by this view. We are the guardians of this particular instance of cosmic awareness, tasked with ensuring its continuity and flourishing. Our ethical considerations must expand to match our cosmological significance, fostering a sense of global citizenship and stewardship for the fragile biosphere that cradles this precious spark of consciousness. Ultimately, the power of this idea lies not in providing definitive answers, but in framing a better set of questions. It invites us to live with a greater sense of awe, to find wonder in the ordinary, and to see the extraordinary in everything from the structure of an atom to the vast emptiness of space. It encourages a mindset of curiosity, compassion, and connection, reminding us that we are all, quite literally, made of the same stardust, participants in the same grand adventure. The journey of exploration is far from over. In many ways, it has just begun. I would love to hear where this line of thinking takes you. Does this idea resonate with your own sense of wonder? What questions does it bring up for you about our past, our future, or our purpose? Share your thoughts and reflections in the comments below. Let's continue this conversation and explore